Hello. So today I'm going to talk about just a couple of fast topics. They're going to be things involved with non-standard evaluation and expressions. I'll talk about a couple of fast environment creation. I mean, not that we haven't had plenty about environments, but I'll give a couple environment functions, and then I'll look at a bunch of non-standard evaluation functions. Okay. So let's look at the environment ones real fast. So the one thing we might still want to do is create environments. So I just want to emphasize, fast way to do that is through the new env command. Remember, we don't want to set a parent or change the parent of an environment, but at any time we can create an environment with parents. Now, a couple of the major places we might put it. Now, parent frame, that's something we might do inside of a function that's being called by other functions. What parent frame does is it does lexical scoping. So it's actually, the parent is in the calling environment of a function. So if this is inside a function, the function that calls that is the parent frame. Okay, so that's one possibility. Another possibility is, oh shoot, I can make one that has E as a parent. I can make one. Other major choices are the global environment. Okay. Let's see, what's another couple? You can put them in the empty environment. That's really the parent of all the environments. Or you can even put one in the parent environment of some other environment. I think this should be and what would be a good parent environment? Parent environment here. Oops, sorry. Parent environment of one of the other ones. So let's see. Parent environment of E3. How's that? So in other words, we have lots of choices. You can easily create an environment. Let's look what these look like. E4. Not anything in them right now. It's easy enough to put things in them. There's a variable x inside there. I'll make that 7. Now let's look. Okay. So in other words, it's easy to create environments on the fly if we need one. Okay, so now that we got past that, let's look at what is the parent environment of E4. We can take a peek at that. Oh. Empty environment. Let's see, does that look reasonable? Yeah, because that's the parent environment of E3, and E3 has a parent environment that's the empty environment. So, yep, just what we thought. So if you ever need to create an environment for doing calculations in, you can do that. Now let's get to the key part. So, basic idea is, how does an interpreter even work from a computer science viewpoint? So if you type in an expression, oops, here it's not an assignment, it's just really an expression. Oops, I'll do a number there, why not? Make it all constants. Okay, and I hit return, what actually happens? Or if I have a value here, and then I have sine of x plus cosine of 2 times x. What happens when I hit return? Or any other command here? Well, essentially this is a string. When I type this in, it's a string. So you can think of this as a bunch of characters separated by with quotes around them. And what happens in just about any interpreted computer language, probably compiled ones too, is the following. So there's really 2 steps. The first step, and I wonder if I'll ever talk about regular expressions. Historically, most languages, a lot of languages written using the utilities lex and yak. That's now classically enough, they're flex and bison. But what these are essentially, one of them is a lexical analyzer and the other one's a context-free language. And what essentially happens is the first one goes over one of these things and says, oh, it tokenizes it. So what that means is it scans across the line. As soon as you hit return, it scans across the line and decides what sort of thing is each part of it. So it goes here and says sign and goes, ooh, I know what that is. That's a name. That's actually a name of a function. It's applied to x. Here, so x looks like a name. Parentheses are actually a function. So they're a function also. Plus, it recognizes as a function. Cosine, it recognizes parentheses as a function. It's going to recognize 2 as a constant, times as a function, and x as a name. So essentially it goes through here and tokenizes, decides what things are variables, what things are constants, what things are functions, calls, sub-expressions, and so on. So it goes ahead and labels all the parts. The second part, the context-free grammar, systematically breaks this up, creating kind of a tree structure. So it's going to look at this whole thing, put it all in one big set of parentheses, go, oh, this is an expression. And that expression is made up of a plus that's adding 2 sub-expressions. So you'll get a branch in the tree that says there's a plus and 2 sub-expressions here. And that's going to go to each of these sub-expressions, go, oh, that's a call, there's a name, sign, that's applied to a variable x, so there'll be function sign and x, and there's a function cosine that's applied to a constant, or that's applied to a sub-expression here. And finally, this sub-expression gets broken up. This is a multiplication, which is a function applied to a constant and a name. So it creates a, so essentially you go from a string, it's tokenized, it's then turned into an expression. An expression really is a tree, and that expression just sits there. If it just sits there, that expression in an environment is a promise, so it hasn't been evaluated yet. Finally, it's evaluated, so the names are all bound to, well, for the most part, so it depends quite, we'll see little exceptions to this, but generally, you look for bindings for the names by going up environments through scoping, you plug them in, you plug the values into the tree, work your way up the tree. Oh, and you're saying, what is this tree anyway? What is this tree? So in prior, there's an AST, abstract syntax tree, that will show us what the tree looks like. And we will take a fast look at that. So it converts that into, this gets converted into an expression, which is a tree. And we look at it and see, this is what we get. So remember I said the first thing it does, it realizes that this should be surrounded by parentheses. It's an expression. There we go, parentheses. Inside there, there's a plus of 2 sub-expressions. Plus, here's a sub-expression and a sub-expression. This sub-expression here is sign of x. Okay, notice those little ticks. Those are put on names. So these are function names. This is a variable name, but they're names. Okay. Then this sub-expression over here is cosine of 2x. So it says cosine of, here's a sub-expression of that, which is 2x, which is really the function times, and then 2, and then x. Notice 2 doesn't have a tick because it's a constant. Okay. So what happens in general? So we can have an expression. Okay. Ooh, look, it's an expression. How exciting. And then that can be evaluated. And there's a function evaluate. So expression, it's been parsed. And we'll see parsing again. In fact, I will show it to you in a little more detail. So, and there it is. So essentially, this is put in, this is parsed into an expression. And then the expression just sits there until it's evaluated. Once it's evaluated, you get a value coming out of it. Okay, so essentially what happens is it hunts around for the values of x, plugs those in, and it says, okay, x times 2 equals something, goes up to this part of the tree. Cosine of that equals something here. Sine of that x equals something here. Okay, now we'll add those two parts together and percolate all the way up the tree until you get a value. By the way, strings can be parsed with the command parse. So let's look at evaluate, parse, text equals, I can put this thing in a text string, sine of x plus cosine. So I'm being extremely explicit, but I'm just really repeating what the interpreter does in R. So here's a string, sine of x plus cosine of 2x. I hope this works. It's text. I'm telling it to be parsed, and then it'll be evaluated. Whoa, look at that. It worked. What if I stopped with parse? Think about what's going to come out of there. What type of thing comes out if I just parse stuff? Okay, if I just parse it, it's an expression. Okay. And I think AST will work on this whole thing. Let me take a peek. By gosh, uh-oh, no, not quite. I parsed it, but now AST, this expression now includes the parse. This is what you get for non-standard evaluation. So instead of parsing this expression right here, it actually parsed the expression parse of text. So, well, it does what I essentially want it to. It says, all right, here's the expression that comes out of this. It's this parse function applied to this string right there. Okay. Surprises abound. Okay. Hey, if you're super curious about Flex and Bison, you just get the urge to write your own programming language. Here was a nice, I'll put this down right here, Flex. This is not really a command here, so you might want to check out this site. Kind of interesting. They just do some examples of Flex and Bison doing some parsing. So, okay. So, why do you want to do non-standard evaluation, or in fact use this evals and parse and deparse? So we have a bunch of commands. Let me mention a few of them. There's quote. There's deparse. Okay. Quote, by the way, changes expressions to calls. It doesn't do a whole lot. It kind of reverses what evaluation does. Deparse takes expressions and goes back and makes them into strings. It's the opposite of parse. Parse takes strings or files, parses them into expressions. Eval evaluates expressions, gives the answers. Call takes functions and applies them to arguments. Any other thing we're going to cover? Do call is another one with a little more control over environments. Allows you to apply functions and choose which environment it'll be assigned in, or which environment looks for variables in, which environment is the enclosing environment, and so on. Allows you a little bit of control. Paste, the various types of paste, especially paste 0, allows you to paste together names, well, variables, and text, strings, to make lines of code, if you want. And we'll look at things like all vars, which will extract all the variables from expressions, or actually formulas also. And anything else? I don't know if I'm going to do syscalls or anything like that this time. So, those are kind of a set of commands. The kind of objects that we work with are things like strings, character strings. We'll look at expressions, okay, which you've kind of seen, right? You parse a string into a tree, you get an expression. Expressions can be evaluated. You get calls, which are a lot like expressions. Functions a lot of times are calls. They're very similar. You get promises, which are essentially expressions that are not being evaluated, they're being waited on. So usually you get promises two ways, through the command delayed assign, which, ooh, I might do one of those later. Delayed assign does an assignment at the time that you need something calculated and not at the time you first set it up or describe it. The same thing with the default arguments. Okay, default arguments. And we'll have names, calls, constants. There's pair lists. Any other type of thing. Substitute strings, evaluate. Nah, that's it for now. Okay. So why would you want to do non-standard evaluation? Well, generally there's just a couple of reasons. You can change the environment where things are evaluated. There's usually a typical environment things are evaluated. You might want to change it. You might want to stop evaluation or do partial evaluation. So in other words, you might want to take a formula, but instead of evaluating it, you might want to just substitute parts of that formula and then use that as a title or as a string or just output it. Only partially evaluated. You might want to piece together functions or expressions from scratch, or even change parts of functions on the fly. You can make your own scoping rules, and you can increase your control over how arguments are processed using non-standard evaluation. So let's look at a couple things. So I'll do the command substitute, then I'll take a little break and finish with another video with some of these other commands. Oh, I didn't even put substitute as one of the ones, and that's the first one I want to talk about. Substitute allows an expression to be partially evaluated. So substitute, so if ever you have an expression coming in an argument or something and you want to save it as text, so you don't want to completely evaluate it, you want to leave it as an expression, but you might want to plug in some parts of it, like some parts of it are data and you want to plug it in, you use the command substitute. So what that is, it has an expression, so it better be an expression, and you have the environment where it looks for things to substitute. And it works this way, follows this rule. If it's a constant, leave it alone. It's just like the problem-solving matrix. Okay, so constants are just left as constants. If a promise, remember that is a unevaluated or kind of delayed calculation. Okay, a promise consists of an expression slot, a slot for a value that hasn't been calculated yet, and the environment it should be calculated in. Well, with a promise, if you have a promise inside your expression, you just substitute the expression in. If a name isn't in the environment that you put in, leave it alone. So that's the partial part of the whole thing. If name is in, evaluate it, substitute it. And you'll see from the homework, by the way, it shows a lot of times substitute has a lot of uses, but one thing is when you're using formulas and such for, you want to use them as text. So you either want to don't evaluate them at all or evaluate them partly.